Okay, so this graph I've drawn here is the graph of y equals sine x. So you'll know, all of you will know, regardless of whether you've taken Math 12 or not, that sine x is the opposite over hypotenuse ratio in a triangle. So you can actually look at what happens to your angle. So on this axis here, these are your angles. I know what some of you are saying. What's with those pi things? Don't worry about this. Okay, this is Math 12 Learning Guide 8-9 right now. Anyway, this is like 90 degrees. This is like 180. This is 270. This is 360 degrees. This is a unit called radians, which, if you haven't done Math 12, you won't yet know. And then this here is your ratio. This is your opposite over hypotenuse ratio. So for now, don't worry about the graphs of these functions if you haven't done Math 12. What you should be able to do is we should be able to, given a picture of the graph, determine what the limit is of this function. And so here's a picture, and all of you should be able to say what the limit of sine x is as x approaches pi over 2. So pi over 2, here's pi over 2. What would be the limit as we approach pi over 2 from the left? 1. What's the limit as we approach pi over 2 from the right? 1. So just looking at this graph of this function, sine x, we can see that the limit as x approaches pi over 2 of sine x would be 1. And we can do the same thing. We just like those other functions. We can take that value and stick it into the equation, and it'll spit out our answer for us. So when you're doing those questions, just make sure that your calculator is set up to radian mode. Okay, put it in, make sure it's in radian mode, and then enter it as sine bracket pi divided by 2 close bracket equals, and your calculator will tell you that that's 1. Now, I mentioned that I'm not going to go into a whole lot of detail on this, simply because those of you that have done Math 12 will find limits and continuity of trig functions easy because you know what the graphs look like. Those of you that haven't done Math 12 don't have a clue what any of these graphs look like, and therefore it's kind of all going over your head. But if we all can remember some of these basic limits, so the limit as x approaches 0 of sine x over x equals 1, and the limit as x approaches 0 of x over sine x equals 1, and the limit as x approaches 0 of 1 minus cos x over x equals 0, if we can remember those things, and so you should write those things down. Okay, so these are the three identities that we need to memorize. And you can, the problem with these ones, of course, is if you try to put 0 in. So if we put 0 in for x here, sine of 0 is 0, divided by putting 0 in here. This is one of these 0 over 0 things. In fact, they're all 0 over 0. But when you actually look at the graphs of these functions, and you can graph them if you like, just graph y equals sine x divided by x, you will see that when x is 0, the limit's 1. Same thing here. This one has a limit of 0. So we're not going to go into more or less why that is. We're going to just make sure that we can use these to do some of the questions. So here's the first one. Limit as x approaches infinity of sine 3 over x. So this is a pretty easy one. We don't even need those identities for this one. If we were working this one out, it's actually, we can just dump that infinity right in here. So if we put infinity in here for x, what is 3 divided by infinity? 0. So this just becomes sine of 0, which if you didn't know what it was, you could enter it in your calculator. Those of you that have done Math 12 will know that the sine of 0 is 0. And so we can just say that limit would be 0. These are the ones that I wanted to show you where we can actually start to use some of those identities. So here, limit as x approaches 0 of sine x over 2x. If we try to put the 0 in, like we always would try to do, we would get 0, sine of 0 is 0, divided by 2 times 0 is 0. Problem. We can't have 0 divided by 0. So this is where we're going to make use of that identity. But the identity says this. It says the limit of sine x over x is 1. Right? That one right there. We don't have sine x over x. We have sine x over 2x. So what we're going to do is we are going to write it like so. We're going to split it up into the limit as x approaches 0 of 1/2 times the sine x over x. Because that's really the same thing. 1 times sine x is sine x, 2 times x is x. And now, because this is a constant, we could say then this is not going to matter what x is. It'll just be 1/2 times the limit as x approaches 0 of sine x over x. And we know that the limit as x approaches 0 of sine x over x is 1. So we have 1/2 times 1, which is 1/2. So a lot of the questions that you're going to do out of the textbook are going to have these little puzzles in them where you got to try to figure out how can I get, the sine x over x trick so that I know what that limit will be 1. This next example is a little bit tougher, so you'll see how that puzzle part works. So here's a doozy, this one. Limit as x approaches 0 of sine 5x over sine 2x. If we try to put 0 in, 5 times 0 is 0, sine of 0 is 0. We get another one of these 0 over 0 things. So, problem. The other problem is this one doesn't look anything like our identity here, this sine x over x. What you have to remember from that identity, though, is this. It's actually this. The limit as x approaches 0 of sine of x over x. This limit is 1, but these x's can be anything as long as these two are the same. So this could be like this. The sine of 7x divided by 7x, that limit is 1. You could have anything as long as these two parts are the same. So the sine of blah divided by blah is 1. So when I'm looking at this question here, we got the limit as x approaches 0. I'm seeing a sine 5x. What would I like to have in my denominator? I'd like to have a 5x down here because that limit is 1. So I'm going to put 1 down there. But if I add a 5x to my denominator, to keep my expression the same, I need to add a 5x to my numerator so that I don't actually change the expression. So I've done that. Now, I also have the sine 2x in this denominator here from the original question. What would I like to have in my numerator? I would like to have these two things being the same, because I'm going to use also this identity. So if I've got sine 2x in my denominator, I would really like to have 2x in my numerator, because I know that limit's going to be 1. If I add 2x to the numerator, I need to also add a 2x to the denominator, so I haven't changed anything. So this is what I mean by about expanding the expression so that we can generate those limits. So this 5x would cancel with that 5x, that 2x with that 2x, and we really do still just have sine 5x over sine 2x. But I can now say this limit here is 1 times this limit here. These x's would cancel out, so this expression is really just 5 over 2, because those x's are gone. And my second limit as x approaches 0 of 2x over sine 2x is 1. So we have 1 times 5 over 2 times 1, which is 5 over 2. So this is why they're a little bit like puzzles. You got to somehow generate those identities up here, these two, by expanding the expression and adding what you need to make them work. Let's work through this last example here. So with limit as x approaches 0 of 2 times sine 3x over sine 9x. So this is another one of these where we've got to split them up. There's the 2. We'll leave that there. Sine 3x, I would like to have what in the denominator to go with that? I want to have a 3x there. If I put a 3x in the denominator, I need to put a 3x in the numerator. And then I also have a divided by sine 9x, so I've got that in the denominator to still consider. If we've got a sine 9x, I would like to have a what in the numerator? A 9x. If I put a 9x up there to balance my expression, I would need to have a 9x somewhere in a denominator to deal with that. So here's one where we've expanded it all out. Now we can say the limit as x approaches 0 of this. Well, that's just a constant 2. This limit is 1. The limit as x approaches 0 of sine 3x over 3x is 1. These x's would cancel out, so this is just going to be 3/9. And here, same thing, limit as x approaches 0 of 9x over sine 9x is 1. So we have 2 times 1 times a half. Oh, no, 1/3, sorry. Times 1. So whatever this graph looks like, I don't know, is this a picture of it here? I don't know if that's a picture of it or not. But whatever this graph looks like, the limit as x approaches 0 of that function, the y value is basically approaching 2/3. So that's some of the questions that we should be able to do working with those identities there.